Hi everyone. In this lesson we're going to learn how to prove that a quadrilateral is a parallelogram, and this is part 1 of the lesson in which we're just going to practice determining if a quadrilateral is a parallelogram with simple exercises like the ones that you see here. These are the theorems to prove that a quadrilateral is a parallelogram. They are all converse theorems. And in order to show that a figure is a parallelogram, you only need to show that one of them exists. So basically, there are 5 methods to show that a quadrilateral is a parallelogram. Number 1 says, if both pairs of opposite sides are parallel, then the quadrilateral is a parallelogram. So basically with number 1, we're showing that the definition of the parallelogram is there because that's what the definition is. It says that a parallelogram has both pairs of opposite sides are parallel. So if you show that both pairs of opposite sides are parallel, then you can conclude that it is a parallelogram. Number 2 says, if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So you need both pairs of opposite sides being congruent, and if you have that, then the figure is a parallelogram. Number 3 says, if one pair of opposite sides is both congruent and parallel, then the quadrilateral is a parallelogram. So in this case, you don't need both pairs of opposite sides, you only need one pair of opposite sides, but it has to be both congruent and parallel. If you have that condition, then the quadrilateral is a parallelogram. Number 4, if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. So in this case, you need both pairs of opposite angles congruent, and if you have that, then it is a parallelogram. And number 5, if diagonals bisect each other, then the quadrilateral is a parallelogram. So here you need diagonals bisecting each other, and if you have that, then you can conclude that the quadrilateral is a parallelogram. So basically, what we have to do is, in order to show that it is a parallelogram, you have to show that at least one of its properties or the definition are there. And the same thing works for any other figure. So for example, if you want to show that a quadrilateral is a rectangle, for example, you have to show that at least one of the properties that are specific for the rectangle are there. And the same thing for any other figure. If you want to show that a figure is a square, then you have to show that at least one of the properties that are specific for the square are there. I'm mentioning this because in your homework you do have exercises about these other quadrilaterals, but the lesson itself focuses specifically on proving that a quadrilateral is a parallelogram. So it focuses specifically on parallelograms. So with these theorems, now we're going to do our exercises. It says, determine if the quadrilateral is a parallelogram. Identify the theorem that supports your conclusion. So number 1, we have this figure that looks like a parallelogram, but we do not know if it is a parallelogram or not. But the information that we have is about the diagonals, and we can see that this piece is congruent to this piece, and this piece is congruent to this piece. So basically what we're seeing is that the diagonals are bisecting each other, which is theorem number 5 here. If diagonals bisect each other, then the quadrilateral is a parallelogram. Therefore, because we have this information about the diagonals, we can conclude that this is a parallelogram because the diagonals bisect each other. So our answer would be yes. And then I have to identify the theorem that supports the conclusion, and it is theorem number 5. Notice here that I'm just putting number 5 in order to avoid writing the whole theorem. But in proofs, for example, you will have to write this theorem because only us from in our class we know which one is theorem 1, 2, 3, and 4. Nobody else knows which one is theorem 1, 2, 3, 4. This is only for us. And so we know here that I'm referring to this theorem when I say number 5, but nobody else knows. So this is just our method for this lesson. But otherwise, you will have to write the theorem itself. So number 2, what we see is this figure. Again, it looks like a parallelogram, but we do not know if it is a parallelogram or not. And the only information that we have is the information about this pair of opposite sides. And what we see is that this pair of opposite sides is congruent. So this side is congruent to this side. But if we look carefully at our theorems, there is nothing about having only one pair of opposite sides. So this information is not enough to say that this is a parallelogram. Therefore, we're going to conclude that this is not a parallelogram. And we do not have a theorem that supports our answer because we are not saying that it is a parallelogram. So next one, number 3, we have this figure, and the information that we have is that this side is parallel to this side. So we have one pair of opposite sides that are parallel and one pair of consecutive sides that are congruent. One more time, we look carefully at our theorems, and there is nothing about having this information and concluding that it is a parallelogram. This is not enough. We only have one pair of opposite sides that is parallel and another pair of consecutive sides that are congruent, and that is not enough to say that it is a parallelogram. So the answer here would be no, it is not a parallelogram. And in number 4, we have this side congruent to this side and this other side congruent to this side. So basically we have two pairs of opposite sides that are congruent, or both pairs of opposite sides are congruent, and that is theorem number 2. If both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So this is enough information to prove that it is a parallelogram. So the answer will be yes, it is a parallelogram. And the theorem that supports our conclusion is our theorem number 2. In number 5, we have this angle being congruent to this angle, and this angle congruent to this angle. So what can we get from these angles? Because it might not be very simple to see the information that we have, but we have to use the information that we have here to see what is it that we have, which one of the theorems do we have, if there is any of them here. So notice that these two angles, the ones that have one arc, they are alternating two angles because they are on different sides of these, which would be the transversal that is intersecting these two sides. So since these two alternating two angles are congruent, then we can conclude that these two sides are parallel. So basically here we're using the converse theorem that says, or the converse of the theorem that says that if two sides or if two lines are parallel, then the alternating two angles are congruent. Now we're using the converse of that, which would say if you have two alternating two angles that are congruent, then the lines are parallel. So these two angles are forming this Z. Remember that alternating two angles are the ones that form the Z figure. And so that helps us to conclude that these two sides are parallel. And the same thing will be true for these two angles, which have the two marks. They are also alternating angles because they are on different sides of this segment, which would be the transversal that intersects this side and this side. Therefore, one more time, by the converse of the alternating angles theorem, we could say that because these alternating angles are congruent, then these two sides are parallel. And that's what we really have. Therefore, this figure is a parallelogram because we have theorem number 1, both pairs of opposite sides are parallel. That's theorem number 1 from our table. It says if both pairs of opposite sides are parallel, then the quadrilateral is a parallelogram. So our answer would be yes. And the theorem that supports our conclusion is number 1. In number 6, we have these two angles being congruent. It's only one pair of opposite angles that are congruent, and that is not enough to say that this is a parallelogram, because the only theorem that we have about angles is theorem number 4, and it requires both pairs of opposite angles being congruent. The next one, we have the information about this pair of opposite sides, and what we see here is that this pair of opposite sides is congruent. But not only that, we also see that these opposite sides are also parallel. So we have one pair of opposite sides that is both congruent and parallel at the same time. And that is our theorem number 3 in the table. It's here. It says if one pair of opposite sides is both congruent and parallel, then the quadrilateral is a parallelogram. Therefore, here we do have enough information to conclude that this is a parallelogram, and the theorem that supports our conclusion is our theorem number 3. In number 8, we have this figure with actually two pairs of opposite angles being congruent. These two angles are congruent, and this pair of opposite angles are also congruent. Therefore, we have a parallelogram, and the theorem that supports our conclusion is theorem number 4. It says if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. So here, yes, and the theorem that supports our conclusion is theorem number 4. In number 9, we have in quadrilateral BLUE shown below, BE is congruent to UL. So that's the information that we're given, BE congruent to UL. The question is, which information would be sufficient to prove quadrilateral BLUE is a parallelogram? So we want to find which one is sufficient. Given the information that we have, which one of these 4 would be sufficient to show that this quadrilateral is a parallelogram? So let's look at our options. Option number 1 says BL parallel to EU. So BL parallel to EU. And that's what we have right now. We have one pair of opposite sides that is congruent and one pair of opposite sides that are parallel. And if we look at our theorems, this is not enough to say that we have a parallelogram. So this will not be the answer because we want which one is sufficient to say that it is a parallelogram. So that's not good, not enough to say that we have a parallelogram. And then number 2 says LU is parallel to BE. So LU parallel to BE. And that's what we have now. And we have one pair of opposite sides that is congruent and parallel at the same time. And that would be sufficient to say that this is a parallelogram. That is our theorem number 3. And it's actually the same as exercise number 7 here, the same situation. One pair of opposite sides that is both congruent and parallel, therefore it is a parallelogram. So this one, number 2, is sufficient to say that it is a parallelogram, and that will be our theorem number 3. So that's our answer. And if you look at the other ones, those would not be sufficient. For example, BE congruent to BL. If we don't have this and we have only what's given originally, and then BE congruent to BL, that is what would we have with number 3, and that is not enough to say that this is a parallelogram. And with number 4 we have something very similar, LU congruent to EU, so that's what we have with number 4, and again that is not enough to say that this is a parallelogram. So the answer is option number 2, having one pair of opposite sides that is both parallel and congruent. And finally, number 10, we have quadrilateral ABCD. Quadrilateral ABCD has diagonals AC and BD, which information is not sufficient to prove ABCD is a parallelogram. So in this case, we're looking for that one that is not sufficient to prove that the quadrilateral is a parallelogram. Our options, option number 1 says AC and BD bisect each other. AC and BD bisect each other. If we have that, then this would be a parallelogram, because that would be our option number, or our theorem number 5, that says if diagonals bisect each other, then it is a parallelogram. So this is not our answer, because we're looking for the one that is not sufficient. This would be sufficient to say that it is a parallelogram. Option number 2 says AB congruent to CD and BC congruent to AD. With number 2, we will have both pairs of opposite sides that are congruent, which is enough to say that it is a parallelogram. That will be our theorem number 2 from the table. So that is not our answer, because we're looking for the one that is not sufficient. And the next one says AB congruent to CD and AV parallel to CD. So this would give us one pair of opposite sides that is both congruent and parallel at the same time. And that is enough to say that it is a parallelogram, because that is our theorem number 3. So by elimination, our answer must be number 4. That should be the one that is not sufficient to say that it is a parallelogram. And let's see what we have here. It says that AB is congruent to CD and BC is parallel to AD. So we have BC parallel to AD, and indeed this is not enough to say that it is a parallelogram. Therefore, that is the answer that we're looking for, the one that is not sufficient to say that it is a parallelogram. So that's it for today's lesson. That's how we show that a quadrilateral is a parallelogram. And basically what we have to do is you need to show that one of these conditions exists in order to say that it is a parallelogram. So that's it for today's lesson. As always, check the website to see what is the homework.